Hey everyone, today we're looking at a power of 1, 0, a negative, and a fractional power. Now let's begin with a power of 1. Now anything raised to the power of 1 is equal to itself, and this is quite explicit because an exponent suggests how many times we see that number being multiplied by itself, right? So say that 3 is raised to the power of 2, then we'll only see 3 being multiplied by itself twice. So when 3 is raised to the power of 1, we can only see it once, and there is no other factor it's being multiplied by. Thus, it just becomes itself. Now when the power becomes 0, anything raised to the power of 0 is equal to 1. And I can prove this to you vice versa by saying that 1 is equal to, say, 3 over 3. Now, since we looked at the previous rule, we also know that 3 over 3 is equal to 3 raised to the power of 1 over 3 raised to the power of 1. After that, we can apply the quotient rule, which states that if the bases are the same and they're being divided by each other, we can simply subtract their exponents. And no matter what number I replace 3 with, say 1 is equal to 4 over 4 or 87 over 87, I'll always be left with that number raised to the power of 0, because whatever the base is, it will always be raised to the power of 1 because it's itself, and when we subtract 1 from 1, we'll be left with 0. When the exponent becomes negative, we can rewrite the expression as the reciprocal, where the exponent is positive instead. Again, I will walk you backwards through the steps to prove to you that this works. So 3 raised to the power of minus 2 will eventually equal 1 over 3 raised to the power of 2, because we can rewrite this as 3 raised to the power of 0 over 3 raised to the power of 2, right? Because 1 is equal to anything raised to the power of 0, as we saw in the previous rule. Now we can apply the quotient rule and subtract the exponents, and we're going to be left with minus 2. And no matter what I replace 3, or in this case also 2 with, I will always be left with a negative exponent, because we can write the numerator as a number raised to the power of 0, and the denominator as that number raised to a positive exponent. And when we subtract any positive number from 0, we'll be left with a negative number as our power. For any of you who found the previous example a little bit challenging, then don't worry, because this final one, fractional powers, are much more simplified because they're ways of symbolizing radicals rather than proving that they're equal to each other. So any numerator in a fractional power is equal to the power that you're raising the base to, and then the denominator of that fractional power will be the root that you take. So here we have 5 over 2. We'll be raising it to the power of 5, and we'll be taking the square root of 3. Alright guys, hope this video was helpful, and see you in the next video.